All right, you guys, here we are just doing project number 2, forces. So let me get you started here. I want to quickly go over some just key vocabulary and some other things, and then I'll show you, get you started on the project, and you guys can have at it. So here we go. All right, so you guys, first of all, I want to make sure you understand that what force is. So force is a push or pull. You know that it applies to an object. It can either make it go faster, slow down, stop, or change direction. It can also change the size or shape of that object depending on what we're looking at, right? And so if we're thinking about like liquids, it could change the shape. Even some solids can change the shape and size depending on what type of force there is applied to it. And so without force, nothing would ever move. Force causes movement. And so we can see that there's different types of forces. There's frictional force, gravitational force, maybe there's applied force, drag force like this of air pushing up, and that's kind of how we fly. There's spring force, magnetic force, tension force, and buoyant force that we'll talk about a little bit as well. All right, so when we're looking at motion and movement, Newton, we know that Newton came up with 3 different laws that are very important when we're looking at the laws of motion. And so the first law basically states that every object in a state of rest will stay in that way unless there is a force applied to it. Okay, so if an object is at rest or if it's moving, it will continue to do that unless there is an opposing or some sort of force that is impressed upon it. Okay, and so for example, right here, the ball, it could be on a table right here where we have weight pulling down as a force, but we also have drag pulling up. But if they are equal to each other, then no movement will occur. But we can see that now let's apply maybe airspeed to it or something else, or maybe I pick it up and I impress some applied force by pushing it. By doing that, we now have impressed a force, and now we have movement that occurs. The second law is the idea that an acceleration of an object depends on the mass of the object and the amount of force that's applied. Okay, and so if you remember from a previous unit, acceleration is looking at the velocity and of that object. Okay, and so we know that force can equals the mass times by the acceleration. So acceleration times with its mass will affect the force that's applied. So this law describes the motion of an object when an unbalanced force acts upon it. So here's a car. We know that a car, let's say that it's starting out, it's going 20 miles an hour. If we apply some force to it, we can actually cause it to accelerate. And we can do the same thing. So if we have a larger mass, what impact does that have on force? If we have a smaller mass, what impact does that have on force? And so this equation will help us to kind of look at some different things there. Just know that mass and acceleration multiplied together will equate to the force that object now has. Newton's third law states that for every action there's an equal and opposite reaction always. So for example right here, with a jet engine, the jet engine, we have the engine that's putting a force this direction, but we also have flow pushed backwards as well. So, and it's always going to be an equal and opposite reaction. Okay, and these are showing some other examples of that. When we're looking at force of a liquid, it's kind of interesting, and I want to make sure you guys understand this buoyant force principle. So how does buoyant force have an impact on whether an object floats or sinks? And you guys can think about that for a second. And so if you guys thought about that, so for example, let's say that we have a rock. We know a rock will sink to the ground versus like a ball that can float. What's the difference there? Well, the difference is that the force applied down onto it, whether it be gravity or whatever, must be lighter than the buoyant force going up. And so if they have indifferent amounts of force there, then we would see floating or sinking. In this case, we have more applied force than buoyant force in that example, or whatever force this is. Okay? Alrighty. So now that we've gone over some key details there, let's go quickly into the lab. So the lab, you guys, there will be a model or a document that you will download that you will need to answer a few questions on, and then you will use this online simulation to test that. Okay, now it'll go through the information here to solve for these. So choose the motion window to start out. So I'd go to motion. Okay, and so you can see how it just kind of walks you through all this. Make sure the box that say force values and speed are checked. So when you open up this, we want force values and speed checked in. You can even turn on mass if you'd like. Okay, so it shows you those different masses. Apply a force of 50 newtons to the box. So if I go right here, let's see, and I want to put in 50 newtons. So let me type that in. Nope, it doesn't. Okay, so I applied 50 newtons. I actually did more than 50 newtons. Let's restart it actually. All right, so I want to apply 50 newtons. Right there. Okay, so I applied 50 newtons to it. Describe the motion of the box using physics terms such as velocity, acceleration, and displacement. So if you need to refresh back onto project 1, know velocity is not only just the speed, but it's also the direction in which you're moving. Acceleration is the velocity, the change in velocity. And then we have displacement, and distance and displacement are two separate things. So we have distance, which you could travel in this direction, but displacement would just be this. Okay, this straight line. Mine's not very straight. But if we went from point A to point B, this is our displacement. Okay, this is direction. Blah, blah, blah. Very good. And so if I erase that, maybe not. Okay, I guess I won't erase it. All right, and so anyways, you guys answer these questions as best as you can based on that. You'll see that it's going to ask for some different things. For part 2, you're going to test Newton's second law. We are simply testing Newton's first law here, that an object in motion or an object at rest will stay at rest unless it's applied by a force. So we apply a force there, we let it go. You can see it will continue to move in that direction forever and ever. Now, does the speed change? No. We can see that the speed is going to stay like that continuously, continuously, and continuously. Now, we know that in real life that doesn't occur. Why? Because we have force being applied in this direction as well at the same time. And so slowly we would see that slow down. And so you will apply some different things to that as you're looking at some different things. So we know that all 3 laws of motion are at play at the same time, but this model does an excellent job of looking at each one individually. Alrighty, you guys have fun. If you have any questions, let me know.